In this video, I'm going to show you how to do linear and quadratic inequalities for a grade 11 level. So there are some basic rules to keep in mind that you would have learned in grade 10. Firstly is when you're solving, similar to in equations, you want the variable to be positive. Another key rule is that when you divide by a negative number, it means the inequality sign has to flip. So in this example, negative x is greater than 1. We're dividing by negative 1 on both sides because we want the variable to be positive. And because of dividing by negative 1, the inequality sign has to switch to being smaller than. So you can see that it changes orientation. As an important tip, that symbol is greater than. And the way to remember greater than is that I like to think of it, it looks kind of like a 7. So that's how I know that that sign means greater than, whereas the less than sign doesn't look like any number, but the greater than sign looks like a number. And for inequalities, you read from left to right or from the variable outwards. Okay. Another key tip to remember is that for quadratics, so when you have a quadratic inequality, you need to draw a diagram to help you find the correct values. There are some methods where you can use a table, but I'll be showing you the diagram method, which I think is a bit easier to understand. So let's first revise the basics of linear quadratics. So the first one is 2x minus 3 is greater than x plus 7. So like an equation, we want to get this, all the x's or all the variables to one side, all the numbers to the other side. So 2x, let's bring that x over, minus x is greater than, and let's take that 3 over, 7 plus 3. And just like in equations, if you're taking it across the inequality sign, it changes sign. Okay, so that's still the same. You treat them pretty similar to equations. There are just some rules that are different, such as when the inequalities sign flips because you're dividing by a negative. And when we solve it, when we get to the solving part in quadratics, there's some differences. So let's simplify this. X is greater than 10, and that's your answer. Okay. Next example. X plus 5 is less than or equal to 2 open bracket 3x minus 5. So first step, we have to get rid of the bracket. So let's times in that 2. So that becomes 6x minus 10. Let's take over the x to the other side, just to make it simpler so we don't have a negative. Actually, I'm going to bring it over to show you what happens. So x minus 6x is less than or equal to minus 10 minus 5. So now we're going to have negative 5x here is less than or equal to negative 15. And remember, I said we want positive variables, so we're going to divide by negative 5. So this is going to show you what happens now. Because we're dividing by negative, the inequality switches the orientation. It switches around from less than and equal to greater than and equal to. And those 5's cancel, so negative 5's cancel. So that's just x is greater than or equal to 3. Negative 15 divided by negative 5 is 3. Okay, so let's get into the quadratic examples. It's more likely that you will get quadratic questions, inequalities, in tests in grade 11 rather than linear. But it's not impossible to get linear. Okay, so the first step is we have to factorize. Because it's not factorized, we have to factorize. And we know that it's a quadratic because of that square. Whenever you see a square, it probably means quadratic. So let's factorize. This can't be factorized as a trinomial, but as a common factor. So we can take out a common x, and we're left with x minus 3 is greater than or equal to 0. At this point, if this was an equation, you would write this out as x equals 0 or x equals 3. Basically, you're just solving each part, making it equal to 0. You would have made x equal to 0 and x minus 3 equal to 0, which simplifies to x equals 3. But because this is a quadratic, we don't do that same thing. Once we have solved as far as possible in terms of factorizing, we then have to move to a diagram. And because quadratics correspond to parabolas, all we're going to draw is a parabola. And because the a value in this parabola, if you remember, the coefficient of x squared is the a value. It tells us if it's a smiley face or an unhappy face. Because it's positive, it's a smiley face. The two values now of 0, because pretend you've solved x equals 0 and x minus 3 equals 0. The two values, let's call them critical values, or CV, are 0 and 3. So those are your x cuts of your parabola. So 0 and 3. And now we use this inequality sign. We're saying it has to be greater than or equal to 0. So if this is our x-axis line, and now we're talking in terms of the y-axis, we're saying where is the parabola above the point 0 on the y-axis? So it would be everything above this x line that we've drawn. Oh, sorry, this is actually a y line, the x-axis. So everything above 0, we color in, because that's where it's valid, as well as the other part of the graph. If you can see, between 0 and 3, the parabola dips below the x-axis. So it's not valid there because it's negative. We're looking for greater than or equal to 0. In other words, positive values. So it's positive there as well. So now we can write that as our answer. So we interpret our diagram. So x is less than or equal to 0, or x is greater than or equal to 3, which is what we've shown in our diagram. It's from there all the way into infinity, and from there all the way into negative infinity. Okay, so that's how we do these questions. So that's your final answer. Let's do this next one. 3x minus 2 all squared is greater than 3x. Okay, so first let's get rid of this bracket. So we're going to FOIL it out. So 3x minus 2, 3x minus 2 is greater than 3x. 9x squared minus 12x plus 4 is greater than 3x. Let's bring over that 3x. 9x squared minus 3x minus 12x minus 3x will be minus 15x plus 4 is greater than 0. So this is now something we can create a trinomial out of. So this simplifies into 3x minus 4 and 3x minus 1. If you had to perform a FOIL on that, you would get back to 9x squared minus 15x plus 4. So now our critical values, we solve each bracket for 0 to get our critical values. That's not the actual question that we're doing, we're just getting critical values there. So 3x, let me do this in orange, 3x minus 4 equals 0. So x would be 4 over 3, right? Let's do it for the other one as well. X minus 3, 3x, minus 1 equals 0. So x is equal to 1 over 3. Let's draw our diagram. So it's a positive a value, 9, so it's a smiley face parabola. Our key values are a third and 4/3. So make sure to put these in the correct place. Don't put a smaller number to the right of a bigger number. 1/3 is smaller than 4/3. So do still put it in the correct order. And now we're looking for is greater than 0. So everywhere where the parabola lies above the x-axis, because again this is the x-axis, and these two critical values are where the graph cuts the x-axis, and we're looking for where the graph sits above the x-axis, greater than 0. So it's everything over there, everything on the other side as well, because that's where the graph sits above the x-axis. And remember, it's only greater than 0, so we can't include. So it's a circle. As in the previous question, if you saw it, I use closed dots, but for excluded values, we use round dots. And it goes all the way that way and all the way that way. So your answer then is x is less than a third, because you can see that, or x is greater than 4/3, which you can see over there. And that's your final answer. Okay, so let's move on to two final examples. These are still quadratics, but it's in a fraction form. And just like in equations, we want to get rid of fractions. Do something to the equation to change it so that it's not a fraction. We do the same thing for inequalities. So what essentially happens here is that we're going to times both sides by x minus 2. So what happens on the right hand side, 0 times x minus 2 will still be 0. But then on the top of the fraction, we're left with that 2x plus 1. But now we have that x minus 2. But there's something important you also need to note here, is that because it's a fraction, we don't want a 0 in the denominator. So we have a restriction. So x minus 2 solved cannot be equal to 0. So x cannot be equal to 2. Because if x equaled 2, the denominator would be 0. So we need to keep this restriction in mind. Okay, so now let's solve. We now are in the quadratic form, so we can go straight to our picture now. And if you had to solve this, it would be a smiley face parabola. Our critical values would be whatever 2x plus 1 equals to 0. So that would be x equals negative a half, or x equals 2, right? So let's put that in, negative a half and 2. And the question is asking less than 0. So wherever this parabola dips below the x-axis, which is, between the two values. So we now use that as our answer. So x is less than, or x is greater than negative a half, but x is less than 2. And does that, we've got to check now that our restriction over here still is included in this. And it is, because it's less than 2 over here, rather than less than and equal to 2. Okay, so that's that question done. Let's move on to this final question. So for this question, we have to do pretty much the same. Get rid of the fraction, and remember x cannot be equal to 0. Because if it did, it would be undefined. So that's our restriction. But we're timesing both sides by x. So we have x times x minus 3 is greater than or equal to 0. That means our critical values are 0 and 3, because x equals 0, for that piece on the outside, and for the bracket equaling to 0, you would get x equals 3. So let's draw our parabola and put our critical values, 0 and 3, and it's asking us where it's positive, greater than or equal to 0. So it's all the pieces there, and on the other side as well. But look here, we said x cannot be equal to 0. So technically, this means that this is an open dot all the way to infinity, and the 3 will be a closed dot, because this is asking for greater than or equal to in the question. And it's included because it's not part of our restriction. So that means that x is less than 0 or x is greater than or equal to 3. And that's your answer.